So,
yes, sir, very clear.
Okay, thank you. So whenever we are talking about the surface area or the location and allocation analysis, these are the basically two important aspects of the network analysis technique to evaluate the accessibility and optimize the placement of facilities. As I mentioned, like there are a lot of support evidences are there, which is based on the decision support in terms of the decision making in respect to your healthcare, emergency services, transportation, education, utilities, or infrastructure planning. So such kind of analysis basically consider the locations of demand points, such as the centers or the service requests in any of the customers to get the facilities of the particular locations. So the service and area analysis that can be reached from a specific facility within a defined travel distance or travel time, or in respect to the transportation cost, we can say. So there are so many tools are available in GIS where user can take that distances or can measure the identify some of the buffer areas, we can say, to get that accessibility constraint and to provide the realistic representations of the service coverage. But this analysis basically useful to evaluate the response time and ensure the rapid emergency assistance for any kind of decision making process. So for example, like if we talk about the water utilities, so how much area is going to be coverage of the water supply systems? Or let's say there are some hospitals are there. So what is the area that can be provided influence or provide the service of that particular hospital or any kind of education perspective, or some kind of like the transportation agencies? They can use it to measure the accessibility to bus stops or let's say metro stations or transit stops to support the sustainable mobility planning. So in that case, basically, there are most important the required inputs are you need to have a road network layers, which contains the roads, streets, pathways, or their connectivity information. And these networks forms the basis for calculating the actual travel routes and accessibility. And the another major inputs which is required, which is the service location layers. That means like the representation of the facilities or the service center from which the accessibility is being measured. So these facilities may include like different types of infrastructures in any areas, either it can be a urban or the your rural area, or any kind of the disaster perspective or any kind of emergency services. So to understand in more in details, or if anyone wants to do it in the practical application perspective, they might need to provide some more detailed informations like the distance, proper distance exactly. The times need to be considered for as a required inputs. Just in respect to the fastest distance, fastest measurement, he needs to provide the speed or any kind of impediments is there. So like that way, we can use the these inputs to make that kind of analysis, like service area analysis. Now, as we all are know, because I know because I believe that you are all aware about that different types of GIS software platforms are there. But that platforms always may not be available with you because of in respect to their cost, in respect to their accessibility. Because there are most of the GIS platforms, which is in general in the academic organizations, or specifically in India or the developing country, where they have purchased the license, and during our academic purpose, we learn that license, learn that software, and after that, we don't have that access to learn much more, to understand, to do some more analytics, or gathering some more knowledge on the platform. So it is one of the major impediments in respect to the research students, research scholars, and the academic people. But now, there are several open source platforms are also available. One of the most important and very useful GIS platform, which is Quantum GIS, Quantum Geographical Information System, which is freely available, and there are so many tools and functions are available who can use this platform to make this kind of analysis Also, there are several softwares out there, but as it is open source and freely available, I believe that anyone can download from the internet and they can install in their system and directly use this software. And I believe those who are recently starting in the GIS or the geospatial technology fields, they're also familiar with this QGIS. Because there are so many tools and functions are available, which is basically available in our ArcGIS or other GIS platform as well. And you can directly just search on the QGIS and immediately you will get that software. You can download. And then if you have not downloaded yet, anyone, I request you to, in the meantime, you can just download that software and install in your system, because later on we are supposed to use this software only today. Because our major focus is to use the open source platform, how we're going to use for this kind of analysis. So that will be helpful for you to understand much more in details. Now, within the QGIS, there are several tools are available. One of the most useful tools, which is used for the surface area analysis, there is one plugin is available which is called the surface area. So that surface area also available some other plugins to generate the service coverage zones around the facilities based on the travel distance and travel time. You can have another tools like distance to nearest hub, which calculates and visualizes the shortest connection between the demand locations and the nearest service facilities by creating the connecting lines. The distance to nearest hub using the point layers. If you have some point data, so you can use this point data also to identify the closest facilities or the service center for each demand locations and records the corresponding distance information. Also, we can do the shortest path, as I mentioned like in the first slide. It's a part of the network analysis. So in the network analysis, that is one of the most important analytics, which is the shortest path analysis. So through which also user can used to calculate the optimal route between the two or more location based on distance or travel time. So whenever we are talking about the service area analysis, there are different kinds of service area analysis can be done. The most common service area analysis, which is called the distance-based service area, which identifies all the locations that can be reached within a specified travel distance from a facility. And the second type is the time-based service area, which measures the accessibility based on the travel time rather than distance. We can have another important service area analysis, which is called the multi-ring service area. It creates the multiple concentric service zones around the facility based on the different travel distance or travel times. For example, like if you are from the 5 minutes your travel time is there, or the 10 minutes travel times are there, or the 15 minutes travel times are there, then what are the service area you are supposed to be get facilities? Either it can be your market center or in kind of the service facility centers in respect to their educations, the healthcare services, etc. So here we are also showing what are the workflow basically for that kind of analysis. So here you just need to load the data. Here the data will be your road network as well as the service locations, or sometimes you may directly choose your service locations from the screen itself. If you don't have the road layer, then you need to create the network layers, or also you have to create some locations where you need to take the service. And then which kind of service facility you have to analyze, that you have to choose, and then you can create the service facilities areas. Now coming to the location allocation analysis, which is commonly performed to understand the best locations for any type of facilities. Like these tools provides the powerful capabilities for analyzing the transportation networks by calculating the travel distance, times, generating the service areas, determining the nearest facilities, or optimizing any facilities locations based on the demand distribution. So there are two important tools that are available, which is like ORS tools and QNet 3. So both these tools, we need the input data, as like we have mentioned for the service area analysis, the road network, because this is a part of the network analysis. So we need at least the network, either it can be a road network, or let's say if you are working on the water supply perspective, then you need to collect that water supply network. Or someone is working on the electric or power distribution analysis, they need the electric supply network. Because this network give you understanding the connectivity or the lane or the restriction or the network topology to ensure the realistic travel calculations. As like service area, we also have another input which is called the demand point clears. And it represents the locations where services are required, as like village centers or the urban centers or the households or any customers, and other existing facilities like let's say the current service centers for the particular aspects where is available. If you would like to calculate along with the travel distance or times, that also you can incorporate here for this purpose. So as I mentioned, the most important tools like WRS tools and the QNet. So WRS, that means the Open Route Service tools, and QNet, that is based on the QGIS Network Analysis Toolbox 3. So in the QGIS, there's a separate advantage, like based on a requirement, you can plug in any of the any tools, and you can perform your analysis. So when we are talking about the WRS tools that utilizes the open route services with a routing engine to perform the network-based analysis by generating the isochrone or matrix or accessibility tests. Whereas QNet 3, which is the QGIS Network Analysis Toolbox 3, most widely used plugins for the network analysis in QGIS to provide a comprehensive set of tools for service area analysis or the origin destination matrix to calculate the nearest hub locations. So now let's move to the practical implementations, how we're going to use or analyze these tools, and how we'll be able to generate the output, and how this output will be helpful for our decision-making purpose. So before that, I would request to all of you, please install the QGIS software if it is not yet installed in your system. And also I have shared one sample folder. I believe that you all have received the data, or if not, then let me know to whom I can share so that you will get the data. Or I don't know when here it is possible to upload this data. Okay, can you please confirm, have you received that sample data or not?
Hello, sir.
Yeah, have you received any sample data?
Yes, yes, sir. I'm sending it to the participants through mail.
Okay, sure. Please share that. Then we'll take a pause of 5 minutes. So in the meantime, you guys also just open that QGIS platform. So once you open that QGIS platform, you can get this kind of windows. Okay.
Yes, sir.
Or if anyone not yet installed, you can just search in the Google like QGIS. Okay. So you can go to the download option, and in the download option, you'll get this option. So first skip it and go to the download. Here you'll get the latest release and long-term release. You should go with the long-term release, okay? Because what happened as it is an open source platform, there are so many tools, plugins, some bug or patches properly. So better to consider this one.
Sir, sorry to interrupt. Actually, we'll be sharing the session recordings with our participants, so I can share the data with them and the recording so that they can practice it later.
Okay.
Hello.
Yeah. Sorry. You can share the session recording or not?
Yes, sir.
Okay. So okay. So then let's move to that. Let me open that layers that whatever I have shared with you. Okay, so you'll get the sample data. So under the sample data, you'll get 3/4 layers are there. So first here you just change your detail format. So here the We can choose the history shape file because our data is in shape file format. Okay. So these are the data you'll get. One layer you'll get amenities, one office, one is the point sample 2, network sample 2, network. So I don't want to discuss about that vector layers, raster layers, or how we are going to generate the data. Okay, I believe you all are aware on that part. If any doubt will be there, let me know. Then I'll give you some brief view on that. Otherwise, if everyone is okay with it, vector data and the shape file and everything, then we can proceed. So let me first open that root network. Okay. This two data first I am opening. So either you can just select. For opening this data, you just need to select the vector, and you will go to that particular location where you have kept your data, and you can select that the required layer. So you get that kind of data. So this is let's say take an example like this is a road network of any of the locations. Okay. So to understand that which locations it is, you can also find out from here. You can see under the XYZ tiles, that OpenStreetMap will be available. You need to double click on it. Okay, it will be automatically loaded here, and just drag and drop. So you'll get that location. So this is basically in this locations nearest to the barrack or something like that. These locations the data is. So otherwise, let's say you don't have any data also. Okay, so in the QGIS there is another most important advantage is there. We can have another plugin that we can use to download this kind of group network. Yes, that is not available for each and every locations, but most of the urban areas, if you would like to download any data, you can download. That actually I have downloaded from here only, so therefore I'm just giving you some example. So there is one plugin which is called this one, Quick OSM. So you need to go to the plugins and manage and install plugin. Okay. So here you just write Quick OSM. So you can get this plugin tools. Okay. You need to install in your this plugin in your system. As it is installed in my system, so it is asking me either uninstall or reinstall the plugin or upgrade. So nothing is required for me. So I'm not installing right now, not again. So those who have not installed yet, you can see there's the option. Instead of reinstall, you will get the install plugin. So you just install plugin. So once it will be click on it, it will automatically install in your system. Then you'll get this kind of icon in your window. Click on that icon. Once you click on it, you'll get this window, Quick OSM window. There are multiple tabs will be available. You just need to move to the quick query. Okay. So here in quick query, you just put there are so many layers are available. You can see once you click here, you'll get all there are this many of data available. Again, these are the data. It's a open source data first of all. Although there's the advantage, some disadvantages also there. That will come later. Let's first how we can download or acquire the data from here. Let's discuss. So here you need to choose which data you would like to download. Let's say I would like to download the streets, for example. Highway streets. Okay. I'm clicking there. So as I'm clicking, so under the highway street, whatever the type of streets are available in this category, that is means listed in your window box. Okay. From here itself, we can add more data as there is a plugin are there, means plus options are there. Or if you need any layer, there is no need of any layer, you can delete it from here itself. That is up to you. Now here, you need to choose the option, like at which area you would like to download your data. If you have any area of interest, that's a file. If it's open in your window, it will automatically showcase in here. You can choose that particular layer from here. Otherwise, let's say I'm choosing the canvas extent. Okay, canvas extent means like this extent is called the canvas extent. Okay. So within this extent, any kind of this kind of road is available publicly. The system will help us to download the data. So here, next you need to run the query. Once you run the query, it will take some time to collect that sample and store into the temporary database of the QGIS platform. It will take some time, so like 2 minutes. Yeah. Now you'll get that message. The successful queries and 2 layer has been added. Now close this. So you can see for this particular area, I got this much. The road network layers. So like that way, you can also download the data in your study area or in your area of interest, and you can use this data for the furtherance. Now to use this data, what do we need to do? We have to needs the clean and validation. So I'm removing this point here because it's not required for me. So first we have to store the data. So in your local database. So here you need to export the data. So just right click on it. You'll get that menu bar, and then go to the export and save features as that option. And here you can go to that particular folder and you can save it, your data. And also you might change your coordinate reference system here. So currently the system give you an option that it is storing within this particular coordinate reference system. If you need any specific coordinate reference system, you can change it from here. Let's say this is my location, and you can choose any particular CRS system. Not any, you need to choose that the locations, what is the exact CRS system for the particular locations or your local coordinate reference system. You can search it from here. Let's say you can put the UTM. So whatever the UTM related information, it will be available here. And whenever you select, system will showcase that which location it's called, because as you know, the UTM, there's some classifications are there, some zonal classifications are there. Okay, so accordingly it will be placed. So you need to choose that particular locations, and accordingly you have to select that locations, and then you can save that particular CRS system. And then once you give the name, your OK button will be active. Let's say I'll give you one name. I'm creating another folder as a test. Road network. You can see that OK button is active. So once I'll click on it, OK, it is saved in my local system. So I can remove this data for the time. Now the entire data is saved in my local system. In a similar way, I have actually downloaded this two data, which is you can see the road network and the point sample data. So in the point sample data, let's say I'm taking an example like it is a service area of that particular locations of the point. And this is my road network. Okay. And based on that, we'll be able to analyze our service area analysis. So as I mentioned, there are another option is also available for the service analysis. So this service area, basically, there are certain tools are also available to understand about the service area facilities on the online itself. Let's say, let me first go to the region, all the plugins tools, the most important tools, and then I'll come with this tools as well. So here, there's under the network analysis, there's one most important tool which is called the distance to nearest hub, as I mentioned earlier. So these tools first ask you what is your source points layer and your destinations hubs layers. Okay. So you have to provide the source points and the destinations hubs, and accordingly, it will give you the locations of the center points to the nearest destination features and the distance to it. Let's say, for example, like I'm taking a source points layer of the point sample 2 data, which is available with me. And the destination sub layers, you can choose as a road network. And there is one attributes, which is if you have some specific attributes you have identified, you can choose that layers. Let's say, for example, like if you go to that particular attribute tables. So this attribute basically contain these are the data, like some IDs, some name, some slum name kind of thing, or some we can say we can create some new IDs for that each and every point. And that ID should be your unique ID. Otherwise, what will happen, like sometimes during the analysis, if there's a common ID is available, then system may not calculate that particular, the duplicate due to the duplicate location, some error may face. or sometimes you may get the erroneous results as well. So as I mentioned, there are some disadvantages also in this open source data. Like this data as open source, that is means there is no validations happen with this data. So before using this data, we have to validate that information, validate in terms of the spatial validations or geometric, if there is any geometric errors, like that we have to check. If there is any attribute errors, that we have to check, and we make that kind of corrections. So that can be any kind of layers, either points layer or the root layer, or you are working in kind of the polygon layer. Okay. So here, what we are going to do, we are just do some distance to nearest point locations. So my source points I'm choosing as this point sample, but my destination points should be the different. So let me create some sample points, which will be a destination points, or I can create any source points also from where I would like to provide a service of the particular locations to the network nodes. So in that case, I may create a new vector layers. So I'll go to the layer, create new layers, new shapefile layers, and I can write the name source layers. Geometry will be my points. Here I'll choose that this is for which locations. Let me check first. Okay. So accordingly, yeah, that is my exact locations. So I would like to create the source ID. It can have a text only, which 25. Name keep it as a text. So I'm keeping 30, and then I'm creating. So now I'll just generate 2-3 points. I'm saving it. So the source point I'm choosing source, and the destination hub I'm choosing as a point sample 2. And hub lane name is a object types, and measurement unit I'm taking as a meters. Then I'll run that out. So, one second, just. One second. Give me a second.
Hello, sir.
Yeah. nearest half of the in respect to the radial distance of the road network available in this particular location subzone. Now coming to that another points, which is the ORS tools. So that ORS tools again, we can plug in from this QGIS plugin. So you'll get that this kind of open route service routing service tools. And once you install, you'll get this kind of icon in your menu bars. So here you have to add the points, that your source and destination points. Let's say I'm choosing my source point here. And another destination points, let's say I would like to go these locations. So if I would like to calculate the fastest distance locations, so it will, this is my routes, which is the fastest way that we provide. And what is the means like durations that it will take? 0.11 hour, and the and the distance will be 6.71 kilometer distance it will cover within the 0.11 hours. If we want to do the recommended, as I think it will take the same routes because this is the only route that it is the recommended one. And if you want the shortest route, probably it is also providing the shortest route. Let's take some another example. I want the shortest route for that particular location. So it shows me this is the shortest route for that. If I choose these 4 locations, I can move through like that way. And this is the shortest route for that. The locations that I have given, which is approximately about 8 kilometer, and it's need 0.339 hours. So here also you can choose the different types of way of communications, like driving cars or cycling or foot walking. Let's say if I'm choosing the cycling, so what will be the shortest route for that particular locations as well? Similarly, more or less, it is showing the same routes for the shortest for the cycling. Now coming to that, this tools, which is basically giving you the area of influence of the service areas for that any of the points. Like there is an option that isochronous the points. So here you can choose any locations. Let's say this is my locations, for example, and I'm taking a 5 minutes, 10 minutes, and 15 minutes coverage from that start locations. Then what will be my service area that I can cover? So here you can see you'll be able to get that within the 5 minutes, if this is your current locations. So within these 5 minutes, these are the areas that you can cover for your service. For the 10 minutes, as per the routes available, this is the area that you'll be able to cover. And if you consider the 15 minutes, this is the area to be covered within the 15 minutes from that particular location, so on the route services. In respect to distance, let's choose some another locations. I think there is no routes, that's why it's not able to calculate. Let me take another route. Distance may not be working, maybe some issues there with the distance. Yeah, there is some might be there some issue with the distance, because as I mentioned, this is a new plugin. It's like sometimes due to some bugs or patches will be there, or sometimes maybe these tools, because it's open and online tools, might be some error will come. So the distance function is not working, but your time function is working properly. So you can calculate like that way the service areas for the facility. So let's say, for example, you have some multiple points as well. Okay. So in that case, like how will you be able to get that different types of services for that particular locations? So here, the input point layers, I'm taking the point sample 2, which is my input point layers, the point that is available. And the object ID, I am taking the time. Again, similarly, I'm taking 5, 10, and 15 minutes. Okay. So I would like to run the data and calculate that service area of that. All these point locations, whatever I have. I'm assuming these areas might be some education center or the health center, or any kind of data that you can have in your hand. Maybe there are some more points up there, so you can choose some small points locations. So here I have actually there are so many point data was there. Maybe my internet connection is quite slow. That's why it's not running more actively. So as you see, like I have chosen that very few number of points layers. So it is accordingly it will just calculating that service area coverage. So instead of doing this, what we can do, let's just edit that source locations. So some distance locations, okay? And accordingly we'll see that how this works. Okay, you can see that we are getting this kind of service within the 5 and 10 minutes, I suppose, of the particular places. So like that way we can calculate that service area of different market locations or your education centers. Let's say you have a plan to develop some of the opening of the nursery center within the city. So you can choose that which are the locations and how many nursery points you need to be set up in your area of interest, so that it will cover the entire city for the services. So like that way, this kind of analysis you can do. So now coming to the another tools and functionality. Let me close most of the points. So we have another tool which is called Unit 3, right? Again, you can install that plugin, that Unit 3. Yeah, you can see. So this plugin you have to install in your system. So as it is installed in my system, so it is not required to install again. If some upgradation will come, so I may upgrade that. So here you can search the option Unit 3. There are so many sub functions are available in the Unit 3. So here user can calculate that the ISO areas as a contours from the layers or from the points. So for examples, like I would like to create the contours ISO areas from the layers. So I have a network layer of road. starting points. I'm choosing the starting point as a point as sample layers. And here you can choose the distance, basically. You can choose that it is just a standard distance, which is the software is just measured based on the data layers availability. Moreover, you can change that locations as well. Let's say we are choosing the 200, for example. So, and your contour interval, you would like to keep it as a 50, for example. Okay. So here, two types of ISO areas you will get. You may get that vector as well as the raster input from this analysis. And what we are doing the shortest path analysis in respect to the distance optimizations. So we may run that process. It may take some time to run the process because there are so many points layers are there and the network layer is also available. So it will calculate that each and every point distance and then give us the output. So now you can see that it is created the ISO areas from the contours. That means the maximum cost levels along with the intervals. Cost level here is the distance in respect to that we have. Or otherwise, you can get that contour as well. So in the contour, if you go to the attribute tables of the contour, you can get that cost level, which is your distance in respect to that. And 50-meter interval that we kept, so it took the 50-meter interval. Now we can also make that classifications. So let's say we can use the graduated symbol, and our cost level will be the classifications. Instead of taking this one, let's choose some another symbol. So like that way you can identify or to measure. Similarly, you can also calculate any of the particular points or in any of the some point cloud layers as well. Let's say similarly, like if you have some point cloud layers or the polygonal layers, for example. So start point again your point sample data, and here we are choosing as a let's say 500 meters or 2000 meters. Let's take it as a and 100-meter contour intervals. So here basically the difference is like the point outside that network, it will move at the incremental order in respect to its distance, and the measurement will be happen based on the distribution or the CRS system that we have taken care of. So just wait for a few minutes so that we'll get that relevant output, and we'll move to the next process. So based on that required inputs, the system is calculated the interpolated maps of the service locations based on the point cloud data. Because in GIS there are so many sources. Mostly it will be used the point cloud data when you have a huge number of points that are available. So at that time we can use this kind of data to identify that service areas analysis. To understand about that in respect to the distance and the time travel, that locations to be considered for the facilities or the availability of the services. Now coming to that another option, which is the shortest path. So let's say this is my network layers is available. So I have a start point is here, and I have a end point is these locations. So if I would like to calculate the shortest path, so I got the shortest path of my analysis. By choosing the start point and the end point to provide a service or location analysis or identify the locations to get that service in our area of interest. Now coming to the another functionality, which is called the service area from the layers. So here you need to choose first the road network layers, or if you are working on the another network layers, you need to choose the network layers. What type of path you would like to calculate, you can choose according to your requirement. And the layer starts points. There can be a single points, there can be a multiple points. And based on that network layers and your desired locations and the travel cost, we would like to identify the distances that the service can be provided. So see, if I am choosing, let's choose some less area so that you can get that differences basically. So you can see if you are taking the 10-meter distance from this point, so my service will be particular these locations from these particular points. Okay. So if you're taking instead of 10, if you're taking the 20 meters, So this is my service points for the particular point locations. So actually, basically these points are should be some of the nodes, some of the location junction point. Then only will some like that way we'll get that what is the distance can travel for the field distance and can be provided the service from this particular locations like that. Again, it's a very generic way that I am doing, but it should be given that distance, travel time, and all these things, the inputs based on the particular requirement. Like say, if you're doing some services for the health, if you're doing services for the education, if you're doing services for the emergency services. Okay, so all the aspect, the different inputs and input requirement will be there. So that we have to keep in mind, and accordingly we have to give that input parameter so that it will give you the proper output. Similarly, you will be able to do some analysis from the point as well, like based on your network and your start points. And if you are considering the travel cost of, let's say, 200 meters, what will be the service locations for that 200 meters of that points? So you can see this is your location, and if we consider 200 meters, so this is the area that you can provide the service. So like that way, we'll be able to calculate all this kind of the service and location allocation perspective in respect to the isochrones, or generating that routing, or identifying in any of that the facilities to be provided from the locations perspective and location specific based on the desired locations or the available infrastructure in a particular area of interest. The analysis can be carried out with the open source platform. There are so many other tools are also available, but as we are today focusing on that on these two aspects, so we are just trying to explain like how these tools or how these other functions are available and what are the input data, minimum input data is required, and different tools can be used for the different perspective in respect to the different types of analysis that will be helpful for the different types of research and understanding of the aspects, as well as in respect to some practical implementations if required.